Welcome to solverfy.
In this problem, we have some boat with a searchlight on it that's some distance. D is 2,000 feet from the shore, and some car on the shore that's driving down with some acceleration. A is 15 feet per second squared, and we're interested in finding the angular acceleration, theta dot dot, at the moment when r is 3,000 feet, where r is the line that the light traces from the car to the searchlight. So we can define two components of this a theta, where a theta is perpendicular to this r vector, and ar, where ar is parallel to the r vector. Theta dot dot is going to be this a theta vector divided by r. Next, if we want to find a theta, there's going to be some angle phi here, where a theta is just going to be the total magnitude of the acceleration a times sine of phi, because it's going to be the opposite component along this. So it's going to form a component something like that here. So phi is going to be this opposite component. It's going to form a right angle here, and the hypotenuse is just going to be a here. Next, we can determine phi if we define a triangle where d is again the distance between the boat and the shore. X is the distance between the point on the shore that is closest to the searchlight and the car. Then phi can be defined as arcsine of opposite over hypotenuse. So opposite over hypotenuse. And then we can then define a theta as just a times x over r, since the signs will cancel. And therefore, we have a nice expression for theta dot dot, which is that is equal to a times x over r squared. So we only have to find x then, which isn't too difficult since this is a this is a right triangle, so we can use the Pythagorean theorem here, where r is the hypotenuse. So r squared equals x squared plus d squared. X squared is then r squared minus d squared, and therefore x is square root r squared minus d squared, which if we plug in, these are both 1,000 feet times 2 and times 3 respectively, so we can pull out the thousands. So that's r is 3 squared, which is 9, minus d is 2 squared, which is 4, times 1,000 feet, which is just root 5 times 1,000 feet. And we can plug this into our equation. So theta dot dot is just a is 15 feet per second squared times root 5 times 1,000 feet divided by r is 3,000 feet. So 3,000 squared feet squared. And for the units, all these feet will cancel. We'll be left with 15 root 5. We'll cancel the 1,000 with one of these thousands down here, so 3 squared times 1,000, and that'll give us 15 root 5 over 9,000 inverse seconds squared, which are radians per second squared, since radians are dimensionless. And this is one solution. We can also plug this into a calculator to get a decimal answer, which is 15 times root 5 divided by 9,000, which gives us 0.0037 radians per second squared. And those are our solutions.